Today I'm going to show you how we can control a Festo CMMT-AS Servo Drive with Omron PLC using Ethercat. In order to do that, we need to download a few configuration files before we get started. So the first thing we need to do is go to the festo.com website. Up here at the top we'll have the URL link. In the search bar we're going to type in CMMT and we're going to hit enter. Once we open this page, we're going to go over here to CMMT Servo. We're going to click on it. Once it's open, we're going to scroll down. We're going to go to Downloads. Under the Downloads folder, we're going to go to Software. First thing we need to do is, if you do not already have it, go ahead and install Festo Automation Suite. And then we also need to make sure we have the plugins associated with the drive. That would be the second link. And then moving on, we are going to need the Ethercat XML file. So go ahead and download that. And the last file that we need is function blocks for Omron, so we would want to go ahead and download that as well. We have now opened Sysmex Studio. In this particular example, I'm using an NX102-9000 processor in order to communicate with the CMMT-AS Ethercat drive. One of the first things that we need to do is we need to install our Ethercat files that we downloaded previously from the website. In order to do this, we need to go to Configurations and Setup and double click on Ethercat. Once we're under Ethercat, right click on the master and go to Display ESI Library. Once the ESI library opens, you'll go into Install File, navigate to your saved folder location and install those files. Now I already have mine installed, listed here below. At this point, we're going to go ahead and close. Now in order to add our CMMT drive, we can go over here to the right side and we can select it from a list of the vendors. So we're going to scroll down to CMMT. From here, we're going to pick our CMMT drive and we're going to left click and drag it over and drop it. As you can see here, we've got the servo file installed and we're setting up at node address number 1. The next thing that we need to do is install our new function block library that we're going to use a little bit later on in our programming. So let's go to project and let's go to library and we're going to show references. From here, you would actually select the plus, create a reference, and you would go to your folder where you saved this function block library that we downloaded previously. I've already have it installed, so I'm not going to do that at this time. So at this point, we're going to say OK. So the first thing that we want to do is go into our built-in Ethernet IP settings. Here is where you would need to change your IP address. So from here, we're going to go to controller. We're going to go to communication setup. Need to make sure that you're connected through Ethernet, whether that's a straight connection or whether that's through a hub. Here you would want to type in your IP address and you would do a test Ethernet connection. This is basically testing your communication path to make sure that everything is okay. Once that is okay, we can say okay. From here we can hit this little yellow triangle and we can go online. Once we're online, we need to do a synchronization. So we're going to click the little round indicator. Here we get our window telling us what is different inside the project versus what the PLC is seeing. So we're going to say transfer to controller. Once this is finished and synchronization has successfully finished, go ahead and close that. So as we go back online, we can see that our Ethercat is not communicating due to this X in here, and it's saying that it's not matched when I hover my mouse on it. If I right click on the master and say compare and merge, it's going to go out and look at the network. Now by default, the node address is number 1. I've got mine set up to number 10. This is going to vary depending on what you do inside configuration and what you set up as far as your node network inside FAS. So I'm going to make mine match. And so I'm going to say apply the actual network. So we're going to node 10 and we can apply. And now we are synchronized as far as the node address being correct. Now, once you do this, you do have to do another synchronization and download the program. So we're going to go ahead and do that. Go back up here to the top, do another synchronization. Now that we're back online, we can see that our processor is online. We can see that our network node is communicating with Ethercat, which means everything is good. What we're going to do at this time, we're going to go offline. The next thing that we need to do is set up an access. The access is what's going to make communications back to the Ethercat drive. So in order to do that, we need to go to Motion Control Setup, go to Access Settings. We are going to right click and we're going to say Add a Single Access Position Control. Here we can see our access. This is our access name. If I right click, I can rename this, and I'm going to rename this CMMT. This is indicating the name and the access number. We're going to double click on access. Here we need to get everything set up. So If we start from the top and work our way down, we can see that we have a axis is going to be used. We're not a virtual servo, we're actually a servo axis. It's going to be a single axis position control only, and the output device is going to be our physical servo drive. So we're going to assign that. Once we assign the servo drive, we're going to go down to detailed settings. We need to enter in information for the output and input. As we can see here, we've got some red indicators saying that we need to enter in information. So the device is going to be the CMMT for both of the control word and the target position. We're dealing with output, so we need to assign the output control word to the control word, and we need to assign the output target position for target position. Once we have this, we can scroll on down to input devices. We're going to assign the servo to both status word and position actual value. We're going to go over to process data, and we're going to find the input. We're going to scroll down till we get to inputs, and we're going to say this is our status word selection. And the same thing for position control. We're going to go to inputs, and we're going to select position actual value. Once we have this information filled out, we are completed with this setup. Once we have this complete, we can move on down our list. Next thing is unit conversion settings. And under unit conversion settings, we need to match what we got set up in Festo Automation Suite. So the drive is currently set to millimeters, and I'm going to change my commanded position to 1000. I'm going to change my gearbox travel distance per ratio to 1. Once I do that, I can select the operation settings. Once we open the operation settings, we can see that our value in here is way bigger than what we need. We need to change this value. So we're going to change our maximum velocity to 2000 millimeters per second with a maximum jog velocity of only 500 millimeters per second. Maximum acceleration can't go any faster than 500, and deceleration is going to be set to 500. These are user definable variables, so you'll have to set these up to your particular application. Moving on down, we'll go to other operations. We don't have to do anything in here. And limit settings, we don't have to do anything in here as well. This is the homing setting. Home settings are set in Festo Automation. Down here under position counts, we need to change our position counts from encoder to an absolute encoder. And then lastly, we've got our servo drive settings. We need to go to detailed settings, go to PDS state control, click on the down arrow, and select PDS state control by user program. Main circuit off detection, do not detect. Now the next thing that we need to do is we need to tie in our IO mapping to Ethercat. In order to do that, we need to go up to the IO map. Under the IO map, we're going to go to Ethercat network configuration, and we're going to select our drive. Under our drive, we're going to give a variable name to the modes of operation, and we're going to give variable names to input status word and input modes of operation display. The reason that this is important is we're going to use these in our function block library here in a little while. So let's go ahead and do this. Easiest way to do this is you can actually click on this, type in the name that you want. I'm going to highlight this. I'm going to right click and I'm going to say create a device variable with a prefix. I'm going to tell it no prefix, and I'm going to say OK. So basically, Sysmex Studio develops this tag, takes this name, puts it as a tag name. I'm going to do the same thing for status word and modes of operation. And just like that, our tags are completed. Now moving along, our input position actual value, I'm going to go ahead and give this a tag name just so that I can monitor this in a little bit as we are monitoring movement status. I'm going to say none and give that a value. Now that we've got our tags associated with Ethercat, once we open section 0 of the code, we're going to scroll to the top and you should have your Festo motion control function blocks installed. We're going to take the Festo MC Power Home block and we're going to drag it over and we're going to install it. We need to give Festo Home Power a block a name. We're going to call it CMMT Power Home. The axes is our axes that we configured over here under axis settings. So this is going to be CMMT. Once I start typing, it will start to show you a list of things you can select. Modes of operation. As you're doing these installs of tags, just go ahead and hover your mouse over and you can see what it's actually looking for. We're going to create a tag for set modes of operation. I'm going to call it user set mode, and I'm going to hit enter. As soon as I do that, it's going to give me an option to create this as an internal variable or a global variable. I'm going to create this as an internal variable. Now the modes of operation, this is going to be your input tag that we defined earlier under Ethercat. If we start typing in inputs, we'll click on it, input modes of operation display. So this number matches this number. Start homing. This is going to be an internal tag that we are actually going to set to start our homing routine. So I'm going to do this and create this as an internal variable. Timeout is predefined and already set. There's nothing you really need to do here at this point. Moving along to the outside, go ahead and put in your modes of operation. So this is going to be our output tag, modes of operation. Now, homing valid, busy, error ID, and internal information is all external tag information that a user can see. It's up to you as a user whether or not you want to use these tags. I'm going to put an input in here just so that I can enable the power to start the drive. We're going to insert a normally open contact. I'm going to refer to this as power on and create this as an internal variable. This will allow us to manually manipulate the program in order to turn the power on. Next thing we need to do is we're going to right click. We're going to say insert rung below. In this rung, we're going to install our MC reset. So we need to go over here to our toolbox. We need to scroll down till we get to motion control. Once we're under motion control, let's find MC reset. Once we have MC reset, drag it over. Let's give this function block a name. And what this is going to do is anytime that we have an error within the servo, it allows us to reset it from the PLC. I'm going to insert a contact, reset, insert that as an internal variable. Now, one of the things that I like to do is go over here to the outside of it. Let's put it in output. I'm going to call it the same thing as I called the input. And I'm going to actually right click on this output. I'm going to say reset instruction. So when I manually toggle this execute, once this is done, this will actually reset my input bit. So that way I don't have to manually toggle it on and toggle it off. It will automatically do it for me. We're going to insert another rung below. And we're going to go over here. We're going to drag in move absolute. Let's go ahead, give this a name. And our axis is the same as all the others. Now we need to give this block position, velocity, XLD cell parameters. So we need to define these tags. So I'm going to go ahead and do that. Jerk, direction, and buffer mode is up to you whether you want to define these tags at this point. For this testing purposes, I'm going to leave these blank. In here, we're going to actually insert a contact. And I'm going to do the same thing as earlier. I'm going to go up here, I'm going to right click, I'm going to insert an output. I'm going to give it the same name as my input variable. And we're going to right click and say reset instruction. So once I execute move absolute, as soon as it reaches position and it is finished, it will actually reset this. So once we have the move absolute block finished, we can actually go up here. Let's go to file, and we're going to do a file, and we're going to do a save. Once we have it saved, we can go back online, and we're going to synchronize. Transfer to controller. Now, once we're synchronized and transferred to the controller, there's a few things that we need to get set up. We need to get our setup, our modes of operation. We know that this is going to be number 8 according to our manual, so we're going to enter in at number 8. Before we move, we've got to be able to tell it to move to a position. So we're going to go ahead and just enter in a value of 50 millimeters. Make sure you hit enter. I'm going to give it a velocity of 5 millimeters per second, and then the accel will do at 10. And the decel will do at 10. So the first thing we need to do is power on our servo drive. Once we have our servo powered up, let's go ahead and do initializing a home sequence. So we're going to double click on the home. I want to say true. The servo is going to move to home. Once the homing is initiated, we need to go ahead and we need to do a reset on our power cycle. So let's go off, let's go back on. Once we're back on, we can give it a position. We're going to tell the servo to drive to move to 50 millimeters. We're going to right click and we're going to say true. As we can see, the servo drive is moving fairly slowly because we have told the velocity to only move at 5 millimeters per second. As we can see here, now that the position has completed, we can see that our move absolute is false. Now we can verify this by using a couple tools here. What we can do is we can go up here to our watch project and we can look at the input's position actual value, which we entered in earlier as a variable in our Ethercat table. So if I tell my position to give it a position of 25 and I double click on move absolute, say true, we can see that the value of actually moving and that the servo did move to a correct position.